start. So we got it streaming. Just gonna wait to make sure that we're live on Twitch. Cool. So we're there. Um, I'm just gonna do a little intro to this. Basically, we're towards the end of the school year in the northern hemisphere. I mean, my part of the world. We're in May 1st right now, and high school basically ends in about a month and a half. So I thought we'd do a day of math, basically an open discussion where people can drop in and ask questions if they, if there's certain concepts that they need to understand that they're struggling with. We can cover that stuff, hopefully, anyway. And if there aren't any questions, I got some stuff that we can definitely talk about. And this is sort of the opening stream that we're going to do. And what I got planned for today is basically 4 streams, an hour break between each one. So we're going to cover as much as we can, and if people end up liking this thing, we'll definitely do it again. Most likely we'll definitely do it again before the end of the year is up, because there's a lot of content to be covered for high school math, no matter what grade you're in, right? And for those who are new to this, what we're going to do is basically, if we reference anything, talk about anything, I'll provide a sort of a table of contents, try to anyway, provide a table of contents in the description of the video that we're going to load up either on BitChute or YouTube or whatever platform we're on, and I'll try to provide references to any videos that we mentioned that we've done in the past, or anything else hopefully we can cover. Okay, and that's my little intro, and we're gonna do about a 10-minute meet and greet right now. Wait for people to come on, and we'll see where it goes. Okay, so most likely we're gonna start the mathematics about 10 minutes from the time the stream started, and for the next sessions that we're going to have today, we're probably just going to go straight out into mathematics. I might do a little intro just mentioning that, there'll be a table of contents and what we're doing today. Okay, and that's about it. I think we're live. Yeah. And one feature we've added here is basically commands that you can put in. We introduced Nightbot, and hopefully this is working. With last stream it wasn't. Yeah, so we can pop in, the text should be coming on. There it is. So there's certain commands that you can type into the chat for Discord, for Twitch, and there's a program we linked up with the Twitch which is called Nightbot, which pops up either links or information that anybody might want. And I'm pretty sure slowly we're going to grow the number of commands that we have there. Okay, put on the glasses. Hi Riot, how are you doing? Hope all is well. All is good, all is good. It's getting sunny here again, slowly kicking into summer mode, right? Super nice. I hope it's well where you are as well. Slowly we're getting people coming onto the stream. Do a little mathematics. Day of mathematics. I do have a couple of things we can definitely talk about if there's no questions, and a couple of things. I mean, we could talk about anything. Maybe we'll just pick on something, if there's nothing coming up that people need work with, until the word gets out that this is a free-for-all, right? Working from home, beautiful day, 80 degrees, sunniest in Wisconsin. Nice. Sunny in Victoria, west coast of Canada. A little bit of cloudy, but it's really nice. Like, you can tell you're kicking into summer mode by the evenings, right? When the sun slowly goes down and you can feel the summer evenings kick in. That's the beauty of it. Psycho Fox 1. Hi Chycho, loving the positivity surrounding you and your online presence. I was just reading an article you wrote about Iran and wanted to ask whether you think we'll survive peak oil. I don't think this is the right place to ask this though, so let me know when you plan to do another political stream. Yeah, we could definitely talk about peak oil. Not right now. Peak oil is really just math. It's just talking about Hubble or something like this basically came up, and it is math related. Almost everything's math related, right? But peak oil basically states, and it's basically data that the person collected, right? And then he presented the data, and other people have taken that information, taken that data, and inferred things and extrapolated things. And I wrote that article a long time ago as well, right? So there is a lot more information that's come available since that period, but the mathematics of peak oil is legit. Like, my background is geophysics, doing like 10 years of geophysics work, mainly focus on environmental stuff, right? But I studied extraction, I studied resources, right? And basically the model is simple. it's it states that when you put a hole into the ground where you're extracting resources, initially the rate that you're getting the extraction out is slow, and then it picks up, and then it peaks at a certain point, and then it starts dropping off. It's like a normal distribution to a certain degree, if I remember correctly, right? So peak oil basically says that our resources are limited, and there's a certain time frame that we have for a certain amount of resources, specifically oil, to extract that resource out of the ground, right? Now, peak oil on a global level, what's been happening is new technologies been kicking in, like fracking and whatnot, which is getting oil out. But that oil doesn't last as long. Again, related to mathematics, it follows the same curve or similar curve anyway. I haven't really studied too much of the curves of fracking. I've read articles and looked at some of the data, but basically the drop off is a lot faster for fracking wells, right? That's why they're punching in thousands of holes into the ground and doing the explosion, sending the chemical stew that they have into the fracked shale, and then extracting that out and separating the oil from the chemicals. And you know, if you've been in the realm of the environmental realm or geophysics or anything like this, the fracking community tells you it's safe. Anybody else that studied this stuff knows that those chemicals leach into the underground water and stuff like this, right? Aquifers. So there's a lot of mathematics related to peak oil. There's a lot of mathematics related to disruptive innovation, new technology coming on to extract oil. But no matter how you look at it, okay, a lot of the content, a lot of the interpretation of peak oil, there's a lot of it which is fact, which is basically stating that we're using up a lot of resources, and slowly we're going to run out of those resources, and new technology has to kick in to compensate for those resources. What that new technology happens to be is, there's different factions, industries fighting over to be the dominant role, right? Fracking is one of them, and there's a lot of geopolitical stuff associated with that fracking, related to, there's a lot of fracking going on in North America, right? Trying to get that oil, or tar sands, really. Well, in Canada it's tar sands, it's not fracking. There's two different types of disruptive technology that's kicking into gear. One is the tar sands in Canada, and Canada is one of the largest, and I believe there's a couple other large deposits as well. And there's the fracking stuff. So there's a lot of people trying to get that resource to market, right? With Canada, it's about pipelines and taking some serious environmental risk to get that oil out. The other one is for the fracking industry, which is happening in the United States a lot, which is trying to get their fracked oil, I don't know what the terminology is, I forget, to market, which is basically trying to force certain countries to accept their oil and cut off their supply from other countries, which kicked into Russia and stuff like this. So there's a lot of geopolitics involved with that. Okay, we will be doing an open discussion tomorrow to a certain degree. I have some stuff planned. I hadn't planned on going into politics, but we can definitely do that on the Thursday stream. And I believe we're going to talk about cryptocurrencies, and cryptocurrencies is a form of disruptive innovation that's kicked in, which is related to peak oil. It was 35 just 2 days ago. I prefer 80. Yeah, same here actually. In Victoria, it was cold. So let's check it out. How many people do we have here right now? We only got a handful of people. Mathematics is not the ultimate stream for people to come in at a gaming live streaming gaming platform, right? But we'll definitely cover some stuff. So in about a minute or so, if there's no questions regarding mathematics, And if I knew you were going to ask about Peak Oil, I would have prepared some data to cover the mathematics aspect of it, right? Yeah, I'd rather not do the search right now, look at the stuff, look at the graphs, but we can definitely deal with that at some point. Okay. And you know, if people, let's see, we got 10 minutes in, we got like 6 people joining on to a math live stream. That's funny. So what we can do is we can definitely talk about mathematics, okay? And then if anything comes up while we're discussing these things, a couple of things we've got lined up. Anything comes up that you want to expand on or learn more about or talk about more, specifically math related, it could be charts, graphs, data, functions, whatever it is, just post a comment. I'll keep my eyes on the chat, and we can discuss it. I'll interrupt whatever I'm doing and we can discuss whatever it is that you want to discuss. Evening or morning for you? It's morning for me, evening for you guys in Europe. Until the day comes where a majority of us recognize Earth as an extension of ourselves and stop hurting her, we'll all be hurt in turn. I agree with you, man. There's a reason I went into environmental work. Just back in the 90s, it was obvious we're freight train hitting, going off a cliff basically, right? And some of the stuff that they were teaching in university during that period was the 3 R's: recycle, reduce, and all that again is math related, right? You know, they would say reduce, recycle, reuse, right? Now recycling, fine and dandy, it works, but it's not efficient. It still requires energy. Reducing is extremely important, and reusing is extremely important. Back in the 90s, they were emphasizing recycle a lot. Now we're sort of shifting towards reduce and reuse, right? And if you look at the data, at some point we'll definitely hit up the data for environmental stuff, because I've looked at that data a lot in the past. And yeah, let me take down this sign that says we're going to start shortly. Boop. Because I guess we're starting up right now with math, right? 12 minutes in. But basically, I looked at a lot of data in the past, in the 90s, and I'll continue to look at the data regarding the environment, Earth, resources, and stuff like this. And that stuff definitely extends into geopolitics, and a lot of the decisions made by governments, by communities, and us personally on an individual basis are based on energy consumption, based on the resources that we have, right? So a lot of people don't look at that, but one thing mathematics does, it allows you to look at things into the limit, into a certain period of time, right? You know, you can look at a snapshot of the world where we are right now, but to get an idea of what's happening and where we're heading, you need multiple snapshots put together to be able to get a feel for what's happening, to get a feel for the trend, right? For whatever system you're looking at, and energy consumption, population growth, food resources, geopolitics in an extreme way, inflation, deflation, devaluation, education, all of that stuff is, there's a lot of data behind that. And once you start understanding, appreciating what the graphs are telling you, then it's easy for people to see where we're headed and adjust their lives accordingly. Unfortunately, math literacy in huge chunks of the world, especially in the countries where they have a certain amount of burden, a certain amount of responsibility, because they are considered to be first world countries or leading countries in technology. And in general, the countries that have the highest GDP pollute the most, right? And well, that's sort of the way it's been for a number of decades. Slowly countries are going renewable, and we'll see what that trend does. But those people, the people that are living in those countries that are responsible for a lot of the resource extraction and consumption, have to become math literate, to look at these graphs, to look at this data and realize that that is not sustainable. Okay, and that's where, you know, that's sort of the intro to whatever we're going to talk about later. But on that note, since we're talking about looking at graphs and stuff like this, let me show you guys one thing that I one example I use, one of the things I use in teaching mathematics to emphasize the point that there are multiple roads, multiple paths that end to the same result, but some of those paths might have minor discrepancies, minor, not discrepancies, minor differences between another path, right? And one of the ways you can look at this thing is taking a look at functions. Okay, now I have graph paper set up here, white, just straight up white paper set up here. So hopefully I can write everything out that it's sort of for your view it comes out okay. But we'll see. If I start deviating and things don't start, anything that I'm writing sort of seems a little muddled, please post a comment and we'll go over it. But this is one example I use when it comes to talking about functions and how you can represent functions and how you can graph functions and look at the minor differences between two different types of functions, two or three different types of functions, right? So let's assume we're about to graph a line. Y is equal to x plus 2. Okay, so let's say we want to graph this thing. Y is equal to x plus 2. I hope that's coming out okay. Yeah, that looks big enough. Okay, so let's say we want to graph y is equal to x plus 2. Now we've talked about this a little bit in the past, right? We haven't created a whole series on how to graph a line and how to manipulate functions and stuff like this, but we've, you know, jumped around a fair bit. We've talked about trigonometry, logs, and all that jazz, right? So there's a little bit of info regarding this, how to graph a line, but basically this is a line. Looks good. Okay, awesome. The text looks good. So this is basically a line, right? And an equation of a line in mathematics, there's a general form for it, and the general form is this: y is equal to mx plus b. Okay, and in mathematics, if you write a function, and a function basically means for a given input you can only have one output, and again we'll talk about this, create a whole series on this. If anybody has a hard time, you know, you don't have a full appreciation for what functions are, let me know and we'll expand on this a little bit more, right? But basically a function is you can predict what's going to happen. For a given input you can have an output. You have an independent variable and a dependent variable, and right now we have an independent variable in x and a dependent variable in y, which basically means that y is dependent on x. So for us to find out what y is at a certain time or a certain period or whatever it is, we just plug in a certain x and get the y out, and vice versa. If we want to find out when we're going to hit a certain node or certain point, we can put in a value for the y and get a timeline out of that or something like this, or time point out of that, right? But the way you end up graphing a line is basically this: you write your function if it's a linear function, okay, and linear just means line, right? If you think about a linear function, linear, L-I-N-E-A-R, right? Linear, if you look at this is one of the few ones that works this way. If you look at this, linear means line, right? Line R, I guess, right? So the way you're going to graph this thing is you're going to do this. You're going to go to the y-intercept, and b is the y-intercept because if you want to find out when you're crossing the y-axis, this is your y, this is your x, all you got to do is sub in x is equal to 0, because x increases this way, decreases this way, and right here x is 1. You could call this sorry, this is 0, 1, 2, 3, 4. You can call this -1, -2, -3, -4, right? So if you plug in x is equal to 0 in a generic linear function, m times 0 disappears, so y becomes b. So we call b your y-intercept. So if we plug in x is equal to 0, the y-intercept is 2. So when x is 0, y is 2, right? So y goes here. Let's extend this a little bit. Okay. And then your m is your slope, which is your rise over run. Okay. Right now we don't have a number in front of the x. Well, we do have a number in front of the x. The number is 1, but we don't write it, right? So whenever you see a variable by itself, there's a 1 there, but we don't write it because 1, it just implies 1. Every variable is multiplied by 1 to the power of 1 divided by 1, right? But we don't put the 1 in there. It just makes things look messier, right? It doesn't add any value to the function, to the equation, to the sentence, right? So there's a 1 there, and the slope m, let's write this down. So m is the slope, and the slope is rise over run, and your b is the y-intercept, y-int, right? So slope is rise over run, and if there's a 1 here, you can represent it as a fraction as 1 over 1, right? So if there's a 1 here, that's 1 over 1. And the way you graph a line is you go to the y-intercept and you go up 1 over 1. You go rise over run. If this was negative, then you would go down. You would apply the negative to the rise and you would go down, right? So for this, it goes 1 and 1. And to graph a line, to draw a line, right, all you need is 2 points, right? And we have 2 points. And what we can do is just draw our line. So the graph of y is equal to x plus 2 is this guy. Y is equal to x plus 2. Okay. Easy peasy. This is one of the first things you learn in mathematics when you get into functions. When you try to graph functions, you start with a linear function, because linear function, a line, is basically your prime function. It's the lowest functions you can get to. Graphing the slope of a line. Yep, we're graphing the slope of a line. And by the way, this is 1 over 1. If you want to go this way, if you wanted to figure out, get another point off the y-intercept, you could have gone negative 1 over negative 1, because negative over negative is positive, and that still gives you 1, right? Okay. Now in mathematics, just like life, there's multiple ways to get a certain result, right? In general, there's there's something, if anybody ever tells you that there's only one way to do one thing, take that with a grain of salt. Sometimes there's only one way to do something, sometimes there's multiple ways to do something. In mathematics, usually you can write a function in a different way and get the same result with minor differences, right? So this is called a linear function. Now what we're going to do is we're going to graph, okay, we're going to graph a rational function. Okay, a rational function that is going to look identical to this except for one location, 1 point. Okay, now let's draw this. Write down the function in this form, and then we'll go about graphing it, right? So let's say we wanted to graph the following rational function. Y is equal to, I gotta make sure I get this right. We're gonna put x plus 3 in the bottom, and in the top we're gonna go x squared plus 5x plus 6. Okay, that should give us the result that we want. Yeah. Now this is called a rational function, and a rational function is of the following form. Y is equal to, we're going to call this f of x over g of x. Okay, a rational function is a function where the top is a polynomial and the bottom is a polynomial. So a rational function is a function that is a fraction with the top being a polynomial and the bottom being a polynomial. Okay, and a polynomial is basically something of this form where we've talked a little, well actually we've talked, we put out a video on this, a triple set video on this. I wish I had the pop-up to come up. I don't have the pop-up to come up, but if you do chycho polynomial as a search in YouTube, it will definitely pop up. And it's basically a video where we sat down, and I believe it's a triple set video where we talked about polynomial functions. And polynomial functions you can think about as smooth functions. Okay, there are no gaps, there are no holes, there are no asymptotes, there are no breaks, there are no peak, there are no points. Okay, they're not radicals, there are no boundaries really, they continue on forever, and they're called smooth functions, right? Like a line is a polynomial function, and their general form when it comes to writing it out is basically x to a whole number represented in multiple terms with plus and minus separating them, right? Live on my 20th birthday, best gift ever. Live on my 20th. Graphing slow. So let's say we wanted to graph this thing. Okay, now the way it works when you're graphing rational functions, right, is the following. You have to take into consideration the restrictions, the limits of mathematics. Okay, and whenever you're graphing a certain type of function, you always have to think about the restrictions. And restrictions basically for us in mathematics mean the limits of mathematics, or the limits of our understanding of a certain technique, right? For us, one of the restrictions, or the only absolute restriction we have in mathematics, in high school mathematics anyway, I can't remember if we have any major serious restrictions, absolute restrictions beyond high school mathematics. You know, they tell you that there's a restriction of square root of, you can't take the square root of a negative number or even root of a negative number, but that really doesn't exist. You can take the square root, even root of negative numbers, right? They give you complex numbers. So the only absolute rule in mathematics in high school, let's call it high school for now, is you can't divide by 0, right? And because we have a fraction here, then what that means is the denominator cannot equal 0, right? So that means g of x, this function, whatever it might be there, cannot equal 0. So our restriction for this restriction is g of x cannot equal 0. Okay, that's our generic representation of a rational function. This is our rational function that we're going to graph. So what that means is whatever is in the denominator cannot equal 0. So over here we got x plus 3 cannot equal 0, right? So x plus 3 cannot equal 0. That means x cannot equal negative 3, right? Okay, that's easy, because if you put x as negative 3 here, the top becomes negative 3 squared is 9. 5 times negative 3 is 15, a negative 15. So that's 9 plus 6 is 15. 15 minus 15 is 0. The top is 0. That's allowed. Okay, the bottom you got divided by 0. That doesn't work. We can't do that, right? So that we have to keep in mind. So whenever you start off with any function in general, if you're graphing them, no, you haven't missed the stream, you what do you call it? This is our first stream of the day, by the way. We're going to do 3 more after this, just open math discussion. This one we're going to do for an hour. Hello chycho, hello yo. I still haven't checked out the anime that your name's from, by the way. So any function, just recap, any function that you're planning on graphing, the first thing you should do in mathematics if you're trying to graph them is list your restrictions. The only restriction we have right now with this function is x cannot equal negative 3. When it comes to rational functions like this, the one thing we're going to do is, the first step for us to be able to graph them, we need to factor them completely, right? Factor every you know, the top and the bottom. So the bottom we can't factor anymore, the top we can factor. This is a simple trinomial, and we've done videos on simple trinomial. Okay, simple trinomial, the way we factor it, and again we'll provide the link in the description of this video. I should be making actually a little list of all the videos that we're gonna do a reference of, right? So we talked about polynomial. This will save me a little bit of time to put this stuff together, right? Polynomial, line, and factoring. Simple trinomial, right? So when we want to factor a simple trinomial, what we're doing is we're looking for two numbers that multiply to give you the last number, add to give you the middle number. Okay, can you explain the real world applications of these functions, Chycho, just so I have a better understanding? For sure we will. Let me put on my glasses, I can't read the name. Jeannie, yeah, for sure we will, Jeannie. I'll do this example and then we'll talk about a real world example. Okay, maybe a real world example, but we'll kick it up a notch. We'll do a little bit of trig. Okay, and if we don't get the full trig done in this hour, we'll get it done starting in the 12:30 session, because we'll definitely not get it done in this hour. We'll get it done in the next session. Okay, so right now we're looking for two numbers that multiply to give you 6, add to give you 5, right? And those two numbers are 2 and 3. And the way we can do this is we split this up. Okay, x. So x squared becomes xx. If this was x to the power of 4, that'd be x squared and x squared, as long as this guy was x squared as well. Okay, if you ever need to graph anything, you'll need this info, just so I have. Yeah, so two numbers that multiply to give you 6, add to give you 5 is +2 and +3, right? And if we FOIL this out, if you want to convince ourselves that we can do this, here, watch this. Let's FOIL this guy out. Hopefully that comes out okay. It's not dark enough, maybe. Let's do it in blue. Okay, x plus 2, x plus 3. If you FOIL this out, and we've talked about foiling a lot as well, right? X times x is x squared, plus 3x plus 2x plus 6, 2 times 3, and then this becomes x squared plus 5x plus 6, which is our original function, right? Okay, how do you convert a decimal to a percent? Okay, for sure we'll do that, you. I'm pretty sure we'll be able to do that in this stream. Okay, so we factor the top, the bottom. Here, let's write down here percent real life application graphs, and percent to a decimal, decimal to a percent, deci to percent. Okay, we'll cover those. Nice way to keep note of track of what we want to cover, right? So we factor the top, the bottom we can't factor, so that becomes x plus 3. Okay, now what happens in mathematics is you want to be able to, as soon as you have things factored, it's like multiplying fractions, right? Anything from the top can kill anything from the bottom. So after you end up factoring these things, and these are sort of the steps that you take to graph rational functions. The first one, you list your restrictions. The next step, you factor, right? So let me write these down here. Steps, graphing rationals. Okay, first step is find your restrictions. The second step is factor completely. Okay, factor. The third step is, after you factor, you want to reduce. So what happens is, if you can, by the way, basically what we have here, we have x plus 2 times x plus 3, the whole thing divided by x plus 3. And x plus 3, as soon as they got a plus sign between them, that's like they're joined at the hips, right? They're together. So what you can do right now is x plus 3 can kill x plus 3. So this guy can kill this, right? That's us factoring. So step number 3 is reduce. Reduce. Okay. So we've reduced, and what we end up having is y is equal to x plus 2, which happens to be our original linear function we graphed, right? So we got y is equal to x plus 2 here, and we have y is equal to x plus 2 here, which is a weird thing, okay? Because our original function here is not y is equal to x plus 2. Okay. Answer to what's the use of math? A real life question is that math is a language like English, which you can use to explain stuff around life. For sure, but we can definitely do examples on that too, right? So here's the issue we have right now. Because if we graph this original function, if we graph this guy without knowing this information, right, which is really important for you when you're looking at functions, to find out what the origin of that function was. The origin of this function was different than the origin of this function. This function we just wrote out as y is equal to x plus 2. This function is y is equal to x plus 2, but it had an original source material, right? And the source material was this guy here, and the source material had a restriction, and the restriction was that x cannot equal -3. Okay, pretty important restriction. So this restriction, right, that we had up here in this rational function still applies to this guy, the reduced form of this, because the source material of this guy was that guy. So that means this guy has a restriction as well. Okay, so if we're going to graph this thing, let's graph this guy, right? Let's put this guy here. I'm going to make this a little bit bigger, hopefully a little bit cleaner, right? So let's put our points on here again. Okay, so we have x is 0, 1, 2, 3, 4, right? And we got -1, -2, -3, -4, -5. I'll put 5 here as well, and we'll go 1, 2, 3, 4, and -1, -2, -3, -4, right? Now we have a restriction at x equals -3 for this function. That means x cannot equal -3. Okay, but because this part of the restriction, x plus 3, does not occur in the origin, in the final version of the function, we ended up reducing it. What we end up calling that is a hole. That means the restriction of x is equal to -3 still applies to the original, the source material, which means it also applies to the final product, reduced form of the function. Okay, but it's no longer, because if it didn't disappear, it would become an asymptote, which we'll talk about. But because it disappeared, it becomes a hole. And what we need to do is we need to find out what the y is when x is equal to -3. When we first started this, if we found the restriction, if we put x is equal to -3 here, we get a division by 0. But if we put an x is equal to -3 here, we don't get a division by 0. We get -1. So if we go y is equal to -3 plus 2, then that means y is equal to -1, right? -3 plus 2 is -1. That means our restriction for this function, because the source material was this, is the following: x cannot equal -3, and if x is equal to -3, y is -1 in the final product. So that means we have a hole in the function right here. Okay, I'm going to do this in red so you see it better. So we have a full hole on this function, I'm gonna make it big so you see it, but it's not that big. It's exactly at boop, -3 and -1, right? The rest of this function we can graph the same way we did a linear function, the same way we did a line. We go to the y-intercept, which is 2, right? And the slope of this 1/1, right? So we go up 1/1, okay? And if we're going to graph this, this guy comes down like this. It looks the same as this line, right? They're identical except for one location. At exactly -3 and -1, we have a hole, okay? So for us, if we're going to graph rational functions, we find the restrictions, list the restrictions, we factor as much as we can, we reduce, and then we, based on the final product of what we have, we either map out the holes or the asymptotes. Holes, asymptotes. Okay, and we've talked a little bit about asymptotes in previous videos. I can't remember which ones we did them on, right? We might have done them in, I can't remember. We haven't delved too much into it, and we will definitely get into functions in a big way, create a whole series the way we're doing for trigonometry, right? We map out the holes and the asymptotes, and then after that we're down to the last spot, which is basically graph it. Okay, which I think this example is, I really like this example, okay, when it comes to getting a full appreciation of what mathematics is revealing to us, what mathematics allows us to do. It allows us to simplify way more complex functions. I mean, take a look at this thing. This is y is equal to x squared plus 5x plus 6 over x plus 3. We reduce this guy, it looks like y is equal to x plus 2, except for one location, right? And that's the beauty of mathematics. It's got multiple ways that you can get almost to the same result. I've always been average at math. Everybody has, the thing is, math is not absolute, right? Math, well, it is absolute to a certain degree in the way we understand the world, right? But there's different types of mathematics around. Like for me, there's certain type of mathematics that I appreciate a lot more than other types of mathematics. Okay, there's certain type of mathematics that I'm better at than other types of mathematics. I love functions because I like making predictions and stuff like this. I personally don't appreciate combinatorics and permutations very much, or I can appreciate it, but I'm not good at it, right? Because there's a lot of wordplay. So when you when you say I've always been average at math, there might be a certain type of mathematics that you're good at, right? It's just you have to dig down a little bit and try to see what type of mathematics sort of rings true to you. From what I understand, I think you're a gamer. I know you watched a lot of anime and stuff like this, but I'm assuming you're also a gamer. Most gamers that I've come across, that I've taught, they're phenomenal at statistics. They like data. Most gaming is about data, right? There's so much data coming at you from all types of games that for me sometimes I have to pause and think about what that stat means, right? For some of my students that I have, because they're familiar with the game and they keep track of their own data, right, their own stats, they know what some of those variables represent, right? I'm not even gonna what is it, the kill ratio, the how much funds you're getting, how the power levels and stuff. Some of those games go very intricate and stuff in that stuff. So if you're playing those games, you're good at math. You're just using it in the real world without really formalizing it, because that's what this is doing. It formalizes it, right? Da, 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 da. I remember the stuff in algebra. Now I'm doing Taylor series in calculus. Wow, Taylor series, I did that stuff at university. I can't remember Taylor series. I would have to do serious refresh to be able to do calculus again. Once you don't use something in mathematics, just like any language, right? You tend to lose that information over time. It's still there, but it might take a little bit of effort to come back with it, right? To relearn it. That's one of the reasons why musicians, a lot of musicians, will never take a break from playing music, because once you take a break, then coming back to playing your instrument is, or a long break anyway, is very difficult. That's what happened to me. I used to play drums and I took a serious break when I went to university outside of my hometown. I left my drum set behind, and once being away for a year, I came back to try to play the drums. My ability had diminished dramatically, right? That's the same way mathematics works on that level as well, which is why it's important to practice math. Is zero odd or even? It's neither. It's neutral. As far as I know it, you can approach zero from positive or negative direction. I hope you would be okay with doing. Actually, we can do percent, decimal to percent right now. Let's do decimal to percent right now. Okay. As far as zero is concerned, if you have asymptotes on zero or any number, what you can do is approach them from the positive and negative direction. Okay, but let's take this down. Let's do percent, decimal to percent right now. Okay, let me clear this off. Let's talk about decimal to percent. I can't remember if I've put out a video from converting to decimal to percent. I might have, but I don't think I went into it full on, and I will at some point create a full-on ASMR video when it comes to converting from decimal to percent, and fractions put in there as well. But think of it this way. Okay, percentages for us is one thing I've mentioned a lot in the past, is that mathematicians are lazy, right? They try to standardize things and try to reduce the amount of work they need to do, right? Or the amount of computing power they need to understand a certain type of system. And that's what percentages are. Percentages take information and standardize it for us, right? And what they do is they standardize everything to divide it by 100, right? So if we have something like this, 1 over 5, if we have 10 over 20, right? Let's say we have 25 over 25 over 50, okay, and let's put 4 over 25, right? So we have four different fractions here, right? And let's assume we were trying to make a decision to find out which one is larger, which one is a bigger number, or which one is a smaller number, or which one is a better deal, no matter what these numbers represent, right? So for us right now to be able to do this, one way we can do it is we can use a calculator to punch the number, do these in calculators and find out which number is bigger, which number is smaller, right? Another way we can do it, okay, is standardize things over the same denominator, which is sort of playing into the concept of adding and subtracting fractions, right? Because when adding and subtracting fractions, what you want to do is put things under the same denominator. So for us to do a comparison between all four of these fractions without using a calculator, what we can do is standardize them under the same denominator, basically find a common denominator between all four of these, right? Now for 5 we could kick it up to 10, but 20 is already past 10. If we look at 5, 20, 50 and 25, the common denominator is 100. So we can kick this to over 100, kick this one to over 100, kick this one to over 100, and kick this one to over 100, right? Now 5 1/5, to figure out what that is over 100, all we got to ask ourselves is, what did we multiply 5 by to give us 100, right? And we multiply 5 by 20. So if we multiply the bottom by 20, we have to multiply the top by 20, right? Because we can't change the value of that number, right? Like if we want to find out what 1 over 5 is as a percentage or a decimal, you can't just multiply it by a number up top or a number in the bottom. The only number you can multiply it by is 1. So 20 over 20, if we do this as a fraction, 20 over 20, that's 1. So we're multiplying this number by 1. So we're not changing its value. All we're doing is making it look different. How are we making it look different? We're making it to be over 100, right? So 1 times 20 is 20. Okay. Same with this. What do we multiply 20 by to give us 100? We multiply by 5, right? So from there to there, from there to there, we multiply by 5. That means in here we multiply by 5, so that becomes 50. Okay, 50. Over here, what do we multiply 50 by to give us 100? We multiplied by 2, so we multiply top by 2. So we're basically multiplying by 2 over 2, right? So that becomes, the bottom becomes 100, the top becomes 50. Over here, what do we multiply 25 by to give us 100? We multiply by 4, so we multiply top by 4, so that becomes 16, right? So multiply by 4, multiply by 4. Okay. Now we can convert these to decimals pretty easily, because decimal, deci, is multiples of 10. And the way you can think about this is each 0 in the denominator is 1 decimal place that you have to move this guy to the left, right? Because if it's 20 over 100, the decimal place is here right now. It's here right now. It's here right now. It's here right now. So what you can do is, the 100 means move it 2 decimal places to the left. Doop, doop. You go that way. So 20 over 100 is 0.2. You can put the 0 in there, but it's not necessary, right? This one is 0.5. This one is 0.5. And this one is 0.16. Okay. Now over here, if you knew your fractions well, you would have known that 10 over 20 is the same as 25 over 50. If you didn't, this should make it obvious to you now, right? 50 over 100, 50 over 100, they're the same number. So this guy and that guy are identical. This guy is bigger than that guy, so this is the smallest fraction we have, second smallest, and the largest fraction we have is here, right? Now how do we convert to a percentage, right? For me, I always convert the fractions whenever they're over 100 to decimal, and then I go to percentage. And the way percentage works, all we're doing, you can think about it this way, is representing this number in another way as if it was a fraction. So all we're doing is we're kicking the number back 2 decimal places to the right, and we're calling it a percentage. That's basically a pointer for us to tell us that it's really over 100. So the way it works to convert this to a percentage, you take the decimal place from here to there, you move the decimal place 2 this way. If you're taking a number, you're going to convert it to a percentage, you're going to take the decimal place 2 that way, right? So if the decimal place is there, you're going to go 1, 2, and for anything that you're missing, there's no number there, you add a 0. So this guy basically becomes 20%. This guy becomes, you move the decimal place over to 1, 2, you add a 0, 50%. This guy becomes 50%. This guy becomes, you move the decimal place over to 1, 2, becomes 16%. Okay, that's how you convert from fraction to a fraction over 100, which is really what a percentage is, to a decimal, and then to the percent sign. And what I tell my students is, think about these 2 dots, this symbol here, representing 2 movements of the decimal, right? So if I had this, let's write this down here. What if I had the following and I wanted to convert the following to a percentage? 12.765. let's say that's a number and we want to convert that to a percent. If you're going to convert that to a percent, then according to our rule, you take the decimal place and you move it over to, okay, this way, right? So this becomes 1276.5%, which basically means this guy is 1276.5 over 100, right? And if it's over 100, then if you want to go this way, right, you just get back this guy, right? If you have another fraction, let's do another fraction. Let's do a percent to a decimal, right? Let's say you had 0.0075%, right? If you had this as a percentage, and if you want to go to a number, right, not a percent, then what you got to do, you got to remember that this is really 0.0075 over 100. That means you're dividing by 100. If you're gonna look at it as a number, then what you're really doing is moving the decimal place over this way twice. So this becomes 0. So we're gonna have 1 2 doop. So we're gonna have 1 2 3 4, that's 4 zeros. 1 2 3 4 7 5. Okay, that's what it means when you're converting, or that's how you do it when you're converting from decimals to percent and stuff like that. I hope that that answered your question, that gives you an idea of how to do this. It's something that a lot of people struggle with. Like, a lot of people have a hard time converting between decimals and percentages and stuff like that, which is sometimes I've messed it up. I go the wrong way. That's because I'm having brain farts, or I'm doing silly things and not paying attention to what I'm doing. It's a dangerous thing to do if you're doing some kind of serious calculation that you need the answers for, right? I think 0 is technically even by some weird definition that says any even number will be divisible by 2 and have no remainder follows 2n. Oh really? Okay, I don't know some of the technical stuff that they do in mathematics, and some of the definitions and stuff like this. For me, I don't consider myself to be a mathematician. I've just learned mathematics to a level that I'm able to use it in my life, which I think is the important part of mathematics. I'm not a I don't words, definitions and stuff like this, they imply things, right? And sometimes if you use the wrong word when you're trying to say something, sometimes it ends up meaning the opposite of what you're trying to imply. So I sort of go off and repeat myself a fair bit of time, just to, in different ways, trying to make sure that I understand what's going on, or I'm explaining something properly when I'm trying to explain it, right? Or in when we're talking with people, when you're having a dialogue with someone. Okay, so how did you get to that level? To which level? To be able to use math in my life? I consider it as an absence of division. That's a good way. How I got to using math in my life, I needed it out of necessity, right? For me to be able to do geophysics, I needed to learn mathematics. For me to do comic book publishing, I needed to crunch numbers and present a business plan and do financing, so I could, make sure I could publish the comic books, right? For me to be able to buy things, I save money. I have to manage my money to a certain degree. For me to build things, I have to know mathematics. Like, for example, I built this bookshelf, right? I had to measure things, I had to divide things, I had to multiply things, I had to think about how I was going to incorporate things so they would fit what I wanted to fit in there, right? And sometimes you have to take a step back and readjust your calculations. So it's just out of necessity. It's just out of necessity, and we need to learn how to. Right now, all of us need to know mathematics. We need to be literate in the language of mathematics. That's the way the world is going. Mathematics is the backbone of our geopolitical economic system. It's the backbone of science. It's the backbone of everything we know. Do you consider yourself an self-taught person, or do you prefer formal education? Tricky question. Most of what I know, most of what I found useful is self-taught to a certain degree. I've gone to university. Please keep in mind, I don't consider university to be useless. I've got, for me, I stayed focused and I went to university and I took the courses. I took extra courses to make sure I understood what I was doing as well as possible. Even back, now that I look back, a lot of things I took I understood. I really didn't understand, and the courses were pretty useless, but they were a good introduction. They allowed me, they were a stepping stone for me to be able to get to where I'm going right now. So it's a mix of formal and self. For the way I interact with the world, it's self-taught. University or formal education doesn't really tell you how to interact with the world. It tells you about certain types of systems that are disconnected to a certain degree. Once you enter the real world and start experiencing, that's one reason I said one of the best things you can do regarding personal finance and acquire experiences is because once you start taking some of the knowledge, formal education that you have, and using that in the real world to manage your life, to do what you want to do in your life, that's when you really start to understand what it is that you're doing, what it is that you learned. So it's a mix of both, but self-taught is huge, huge, huge. That's why I have so many books. That's why I listen to a lot of audiobooks, lectures, articles I've read and stuff like this, and experimented. Self-taught is also doing and making mistakes, because you learn way more from mistakes that you've made in your life than things you've gotten right. Okay. Yeah, I publish comic books. If you look at the previous live stream that we did, I talked about that mermaid publications, and I showed you guys eye for an eye comics that I published. They're fun, and we'll get into that a lot more in the future. So listen, gang, how about we take a little break, take an hour break, okay, and we'll come back at 12:30. That'll give me time just to stretch a little bit and give people the opportunity to come down and stagger these sessions, so people, if they have other questions, we can talk about more things. I'm personally thinking about starting my own manga series. Awesome. What would be your tips in regards to indie manga comic creators making money in this digital age? I'm thinking about writing and illustrating it down the line. I would say start doing it. In terms of, if I was doing publishing comic books again, and I might at some point, I would say start doing and releasing pages for free online, and start showing people, proving to people that you're serious about what it is that you're doing. That's one of the reasons. That's a business decision you have to make. I think that's the business decision, the way the world is going. Peace, Psycho Fox. Hopefully we'll see you in the next streams, and I'll just finish by replying to you. So one of the things with the world right now is to prove that you're serious about what you're doing, which is one of the reasons that I started doing this stuff 10-12 years ago, producing online, and I'm here right now. And I have some people that have been following my work for a number of years, and they know that I'm serious about this. And I think that approach is what you need to do if you want to publish a manga or comic book series. I think what needs to be done is do your work, start releasing 1 page, 2 pages, 3 pages, 5 pages at a time, releasing them in segments. And what's going to happen is you're going to start getting feedback, and from that feedback you can improve what it is that you're doing. Because no matter what that you're going to do, you're not going to be the best at it when you're just starting. So use that initial opportunity that you're going to show people that you're serious about this, that you can create a lot of content. Use that as a learning curve to get feedback from people to improve your work. That's what I would do if I was doing comic books and stuff like this. Okay, gang, so I'll see you guys at 12:30. Okay, and we'll continue this math, whatever it is that we're going to do. We'll give 5 minutes at the beginning to see if anybody has any questions. Otherwise, we'll jump into another topic. Okay, I'll see you guys hopefully in an hour, if not in future streams. Bye for now.